So in this screencast, we're talking about some of the problems that you guys worked on page 124. This is number 9 that was asked about on page 124. And we're working word problems, organizing them with charts, as we just mentioned here in class. And across the top, I've written that equation, wage times hours equals the amount of money earned. Okay. So as you read through number 9, we talk about Brian earns as much money each week as earns twice as much each week tutoring than he does pumping gas. So we've got tutoring, we've got pumping gas, and then we've got his sister that comes into the mix. And so as I organize my chart, I want to fill out information in this chart. And we've said before that we'll know all of one column. We'll know all of one column. So as we read through here, it says earns twice as much each week as a tutor that he does pumping gas. His total weekly wages are $150 more than that of his younger sister, and she earns 1/4 as much as Brian does as a tutor. Now, how much does Brian earn as a tutor? What do they not mention the whole time? Yeah, the hours. So what we're left with is an opportunity here to say, you know what, let's just plug in however many hours we want to. The system really is dependent upon what we choose. Now, it says earns as much each week as a tutor as he does pumping gas. So let's just suppose that he works 10 hours doing both. All right. And between pumping gas and tutoring, which one is the one that we're asked about at the end of the problem? It says, how much does Brian earn as a tutor? So why don't we let that be our unknown? He earns X dollars an hour tutoring. Okay. Now here's the kicker. Campbell, how do I express how much he earns an hour pumping gas? Read that first line. It says Brian earns. So you have what? You said P. I don't know what P is. You let P be for pumping gas. How I've got it set up here is where the tutoring is X. So what do we think there, Mr. Wilson? Well, as I've got it set up here, instead of 2X, we want 1/2 X.
I was thinking put the tutoring.
Now, one of the things Wilson just mentioned, if you didn't hear him here on the screencast, he said, I like to let the smaller variable or the smaller quantity be my variable. A lot of times that's how we've said to work this. And indeed, if you let your pumping gas be your unknown, if you said like, hey, I'm going to let this be X, then up here this would be 2X. So you could work it either way. The reason I've set it up this way is because they actually asked for, in the problem, they said, how much does he earn tutoring, not how much does he earn pumping gas. So when we solve for X, we'll already have the solution to the problem. Now his sister, it says, his total weekly wages, $150 more than that of his younger sister. So how do I calculate his total weekly, earnings?
X minus 150.
Well, let's look at it. I would actually multiply from left to right and get 10X. I'd multiply from left to right and get 5X. And that totals up to how much? So our equation that we're going to write, 10X plus 5X, is going to be 150 more than that of his younger sister. 150 more than how much his sister earns, which I haven't addressed just yet. So if I can come up with an expression now in terms of X for his sister's money, then I'll have my equation. Okay, that bottom right-hand corner, that's what we oftentimes use in our chart to come up with the equation. Now, Aiden, question.
So I'm just going to, for the sister, the wage, wouldn't it be 1/4 X?
Very good. So it says she earns 1/4 as much as Brian does as a tutor. So her money would be 1/4 of that. Now, it doesn't say... It doesn't give her information in terms of wages, so we really wouldn't know. We don't care. But 1/4 of how much he earns, how much does he earn? He earns 15x altogether. Or does it say just tutor? It just says tutor, excuse me. So that would just be 10x. So very good. We've got now one equation in terms of our one variable. We didn't necessarily know much about his sister other than the fact that she earns a quarter as much as he does. So his total weekly wages are 150 more than that of his younger sister, and his younger sister's is a quarter of what his money earning is just from tutoring. So now we've got our equation. We've written up that third step. Fourth step would be to solve it out. Let's see if we can do that. Combining like terms. Robert, on the left side, what do we get? Good. So we got 15x. Over here on the right, a fourth times 10 gives me 5 halves. X plus 150. And I was talking about this type of equation with my freshman yesterday. It's got a fraction in it. If I don't want to have a fraction in my equation, Matthew, you got any ideas how I might get rid of that fraction? Not necessarily multiply by the reciprocal. Now, in this case, that actually would work. And you know what? Let's go ahead and do that. The answer that Matthew gave us said multiply by the reciprocal. I was just thinking multiply by the denominator here because although 150 and 15 are both divisible by 5, it won't always be nice like that. Let's go ahead and multiply everything by the reciprocal, though, since that's a good option for us here. So the reciprocal of 5 halves, Thomas, will be what?
2/5.
Good, 2/5. So I'm going to multiply 2/5 times each term, bless you, times 2/5. And then we'll start canceling some things out. So we got 6x. 5 goes into there. 30 times 2 is 60. And then, of course, the two reciprocals here just cancel out. So we'd subtract x from both sides, get 5x equals 60. Divide both sides by 5 and get x equals 12. Is that a reasonable answer? X equals 12? $12 an hour? That's not reasonable? Well, I tell you what, if I was tutoring back in whenever this book was written, 1990, and I was a kid and I was going to make $12 an hour, I'd be very happy with that. What would be like an unreasonable answer?
It's 235.
Well, I was thinking like a negative number, right? It's like, please, here, I'd like to pay you so that I can tutor you. Please, let me have the opportunity. Now, like an extraneous solution, did we give that vocabulary word earlier in the week? We talked about extraneous solutions. Right? In the context of a word problem, it wouldn't make sense for me to say, hey, this guy has negative dollars. Or if it was like, something obscene like $1,000. Now, Campbell, you're doing a good job looking it up in the back of the book to make sure we did it right. Does that jive with the answer? How much does he earn as a tutor? Good. So we didn't quite finish the problem out. I'm glad I saw you looking there. This was his wage. It says how much does he earn? So we want to know what 10x is. So 10 times 12 will be 120. So he earns $120. All right. Now, we took our time going through that problem. The chart sort of helped us organize some things. What was the hardest part of it? Writing the equation. And again, we've said that time and time again, it will be the hardest part, writing the equation. Grady, you had a question.
What if, like you said, 8 is the hours?
Man, what a good question. So if you didn't hear what he said, what if you had picked a different amount of hours? I used a phrase earlier that you might not have picked up on. I used the word dependent, okay? This is a dependent system in that really it doesn't matter how many hours we choose. I just picked 10 because 10 is a nice number, right? We could have picked a different number of hours and it would still have worked out the same way. I'll show you what I mean. Suppose we had picked 8, I think was the number that you had given. 8, we would have had 8x and 4x, okay? And look at our equation. So 8x plus 4x would have equaled 150 more than a quarter times how much he earned tutoring. So 8x. And you solve that equation and you're still going to get x equals 12. Because the difference in the hours comes out on both sides. It's reflected over on the left in that here we would have 12x instead of 15x, and it's reflected over on the right where we had a quarter times 8x instead of a quarter times 10x. Go ahead, Matthew.
When it says twice, it's just 1/2.
Well, and yeah, that goes back to I think Wilson's comment about which one do I let my variable be? So I chose to let my variable be how much he earned tutoring. That's why I used 1/2. If we had done it differently, if we had said, hey, let X be the amount of money he earns pumping gas, then 2X would have been the amount of money he earns pumping or tutoring rather. All right, Wilson.
Does this mean that his sister makes negative $30?
Not at all. She makes a quarter as much as he earns tutoring. So a quarter of 120 would be $30. She would earn $30 doing whatever she's doing. Does it tell us what she's doing? No. Maybe she tutors. Maybe she just tutors for less. All right, so that's number 9 in a nutshell. Talking about setting up a problem here using a chart. We've got a little bit of time left on this screencast, so let's look at one more example if anybody has one they want to ask about. Aiden.
Number 13. I got -3 and 5.
Did you check with Bob?
No.
Oh, wait a sec. If it's talking about how many cars they each sell, -3, we definitely know is going to be accurate. So let's take a look at this. It says, in March, Rodney sold twice as many cars as Greg. Okay. So we got Rodney, we got Greg. In April, Rodney sold 5 fewer cars than he did in March, while Greg sold 3 more cars than he did in March. If they sold the same number of cars in April, how many cars did each sell in March? All right, so check this out. The way that we're going to structure our equation, look at the second to the last sentence right there. It says they sold the same number of cars in April. So the number of cars sold by Rodney in April is going to be equal to the number of cars sold by Greg in April. That's going to be the equivalency that we look for. If I can come up with an expression for both of those, then I'll have my equation to solve. Campbell? Yeah, certainly. All right, so let's start off. It says in April, Rodney sold 5 fewer cars than he did in March. Okay, so again, if we're trying to express how many cars Rodney sold in April, 5 fewer than he did in March. So this value right here is going to be, when 5 fewer is in the mix, we're going to say something -5. And then we're going to have how many rods sold in March. All right, see how we're sort of piecing this together? So the number of cars that he sold in April is going to be 5 less than the number that he sold in March. Now, if I'm working a problem like this at speed, or if I'm on a test or something, I'm not going to write all these words out, but this is what's going on in the mind as you're working through the problem. Grady.
What is it in April instead of March? Because it's 5 less.
Well, I'll read it again. It says in April, okay, so in other words, this quantity right here is going to be the same as 5 fewer than, so that means take 5 away from, how many he sold in March. So how many he sold in March. Now, I don't know how many he sold in March just yet, but when it says in April he sold as 5 fewer cars than he did in March, like for example, if in March he sold 12 cars, he would have sold 7 in April. Okay, so that's the idea. So we're dealing with this in terms of a concept. We haven't put numbers to it just yet. Okay, now it says in March, Rodney sold twice as many cars as Greg. So why don't we say, I'm going to declare my variable. I'm going to say let G equal the number of cars sold by Greg in March. Now I can say, all right, the number of cars that Rodney sold in March is going to be twice as much as Greg. So in other words, 2G. So the number of cars sold by Rod in April is going to be 2G minus 5. Now I've got one side of my equation. And now I'm just looking to come up with the other side of the equation. So we declared our variable. That's step 3. Now we're working on writing our equation. So now I need to figure out how many cars Greg sold in April. All right, it says Greg sold, this is the second part of the second sentence, Greg sold 3 more cars than he did in March. How many did he sell in March? No, how many did he sell in March?
3 less.
No, how many did he sell in March? Read. Somebody said it. Go for it. He sold G cars in March. And if he sold G cars in March, and he sold 3 more than that in April, G plus 3. And that's how many Greg sold in April. And now, holy cow, what an easy equation. The hard part was writing it. The hard part was coming up with it. But did you notice how we organized things? I was writing things down with words. We were contemplating, okay, what should I let my variable? In this case, we picked the smaller quantity, right? We said, okay, if Rod sold more cars in March than Greg did, then why don't I let Greg's be the unknown, and we can use multiplication in this case, twice as many. We say 2G for that. And then with this equation, it's cake now. Like, what do we do to both sides? Go ahead, Peter. Subtract G from both sides. Very good. And how about we add 5 to both sides? So we get G equals 8. Now, the rookie would say, aha, I'm done. Move on to the next one. Right? We're not rookies in this class. What we want to make sure we do is answer the question. Step 5, right? So what did they say? They sold the same number of cars in April. How many did each sell in March? So I've got how many Greg sold in March. All right, so Greg sold 8 cars in March. How about Rod? 16. Very good, Chase. Rod sold 16 cars in March. Now that fleshes out with having sold twice as many as Greg did. Now, let me go ahead and I'm going to ask a follow-up question. How many did each sell in April? Okay, can we follow up with that? How many did each sell in April? Well, think about it. Rod sold 5 fewer than he did in March. So if Rod sold 16 in April, how many did he sell in March? He sold 11 in March. So Rod sold 11 in March. Greg sold 3 more than he did in March. Excuse me, I apologize. I should have written, I think I missed, you guys in red here, it should be April, right? Sorry about that. No, that's accurate. G was how many he sold in March. I'm just losing my brain here, sorry. So March. And then down here in green should be in April. Yeah. All right, so if Rod sold 11 in April, Greg sold 3 more than he did in March, so 3 more than 8 would also be 11. So if Greg sold 11 in April, then that makes sense because they were supposed to both have sold the same amount. Now, did I use a chart to organize this problem? No, you don't always have to use a chart to organize your problem. But what I would suggest, whether you use a chart as we did in the last example, whether you make a drawing like we did in class the other day, you can use a chart, you can use a drawing, or you could just use words like we did here. And you're making sense of all the information that's given to you. One way or another, organize the problem and figure out how to write the equation. All right, that's all for this screencast, and we'll call it quits here, and we'll continue working with some of these word problems. All right, let's try this.